We're going to talk about linear regression today. Fishermen in the Finger Lakes region have been recording the dead fish they encounter while fishing in the region. The Department of Environmental Conservation monitor the pollution index for the Finger Lakes region, and the data table below shows this information for the past 8 years. Well, apparently this problem is pretty old because 1987 was not 8 years ago. But if we take a look at this, the year is actually not exceptionally relevant. That's just when they took each of these pollution indices, because it's telling us in problem one that they want the independent variable, or the x variable in this case, to be the pollution index, and the y variable, which we know is often the dependent variable, is the death. And so that's something that we want to keep in mind as we do this problem. So what I'm going to do is I'm going to show you how to get a line of best fit or a linear regression equation on the calculator. Um, I don't know who did that, I'm sorry. Oh, there's a syntax error that doesn't even, that's really sad. Um, okay, so if we're going to do this and we want to type these values in, the way that you do this is you hit the stat button and then you go to edit, stat, then edit. And then you type in all of these values. So it's asking you to use pollution index as the X and deaths as the Y. You type them in as ordered pairs. So 2.5 goes with 147, 2.6 goes with 130, 8.3 goes with 210, and so on. And so that's something that you can see from the values. When you type these into L1 and L2, when you hit enter, what will end up happening is you will move down. So you'll hit 2.5, enter, 2.6, enter, 8.3, enter, and so on. I just tried to save some time by typing them in ahead of time. Okay, so we take all of this information, the relevant information that they want, and then we type it in, and then they want us to produce a scatter plot. So then what you will do is you'll hit second, y1, or y equals. Notice that the blue says stat plot. Yours will likely say off, off, off. I'm going to click on enter for the first one and change it to be on. Okay, so yours would likely have the off being bolded. If you hit enter when it's on, now the on will be bolded. The first type is a scatter plot, so everything else is fine. X is L1 and Y is L2. That's exactly what we wanted. So now we just hit graph and we should be able to see it. Oh, well, that's not good. My window is from -10 to 10. So that's not actually getting me what I want. If I want to get my statistics visible, I go to the zoom button, then I hit number 9. That's zoom stat. Zoom, then number 9. Now what happens is my window has zoomed out. So notice my X min and max and my Y min and max have changed considerably. So notice that I have pollution index on the X, deaths on the Y, and I can see something that kind of looks like a line. It's not great, but it kind of looks like a line. So that is the scatter plot. So now let's take a look at what the meaning of the slope would be in the model. Since my Y variable, my dependent variable, is death, so deaths here, and then the independent variable is pollution index. The slope is going to be rise over run, or y over x. So it's deaths per pollution index. Learn how to spell. UTION. So deaths per pollution index. So basically that means is for every one increase in pollution index, I can expect this many more deaths whenever I figure out what the slope is. Okay, so now what I'm going to do is I'm going to determine the equation of the line of best fit. The way that I determine the equation of the line of best fit is I go back to the calculator, and then on the calculator, I hit the stat button again. I hit the right arrow to go to calc, and then I look for linear regression. So notice it's going to give us something in terms of what looks like slope-intercept form. So A is going to end up representing the slope, and B is going to end up representing the y-intercept here. If you choose 8, it will give you the exact same answer, except your A and B will be flipped. So just be aware of that. So x is L1 and y is L2. Now, if I want my regression equation to show up in my y equals without me having to remember it or type it in, follow the following steps. Hit the vars button, and then go to yvars, and hit function, and then you can pick whatever y you want. I will choose y1 because that's the first y that shows up. So what's going to happen is I'm going to get my regression equation stored in y1. And you can do that when the cursor is highlighted by store regec. Then I hit calculate, and it calculates a regression equation for me. So since in this class we always round to 3 decimal places at the end of the problem, this is now uh, essentially the end of the problem because it's asking us to write the equation. So we're going to write 9.607x plus 111.958. So that's 9.607x plus 111 point, and I don't remember what it was, 111.958. So that is the line of best fit, the regression equation for this particular problem. So now what I'm going to do is I'm going to predict the number of dead fish for a pollution index of 10. So that means since X is the pollution index, I'm going to substitute 10 in for X. If I substitute 10 in for X, now remember, since we have to round to 3 decimal places on this problem in particular, and we rounded here, we actually would be double rounding. So we have to be careful. So I'm actually going to, that's a good reminder. We will look at our y equals screen in a minute. But I want to actually look at, oh, hey, look at this. So remember that we set the thing to go on our y equals screen. We set the equation to go on our y equals screen. Notice that we're not rounding here. I mean, it's sort of rounding to like a bunch of cajillionth place, but we're not too worried about that because we at the end have to round to 3 decimal places. So if we're looking at this, 9.607 blah 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 x plus 111.9577727 blah blah and so on. So if I graph, oh my gosh, look at this! It's actually going to graph the line with the actual data values. And so now I can see that if I want to. And if I hit trace and I hit the down arrow, now I'm actually on the line and I can move my cursor all along. And if I type in 10 and hit enter, it's actually going to give me the exact value of this with, I mean, it's rounded, but it's going to a lot of decimal places. So I can say 208.032 is the rounded to 3 decimal places answer for this particular problem. So 208.032 ends up being the prediction on the number of dead fish. So if it asked us to round to a whole number, we would say 208 dead fish. But if it didn't, we would just leave it as 208.032. Okay, really briefly, I will show you how to flip the x and y variables. So in some cases, the independent and dependent variables could be changed depending on the circumstances. In this problem, it's a little strange to think about, but let's act as if the independent variable is the number of dead fish and the dependent variable is the pollution index, then in that case, the slope would be increase in pollution index for every increase in dead fish. So that would be the slope in this particular case if we were going to do that. You do not have to retype everything if you did that. Basically, what you could do is you could go to stat, edit, everything's still the same. Then you can go to second y equals to your stat plots. Notice that that plot is still on. You can change the x list to be L2. So I would hit second 2 and make that L2. Then change the y list to be second 1. Now that's L1. So now if I graph that, my line's still there, but my points aren't. Oh, okay. I probably want to get rid of the line because I'm going to need a different one anyway. And then I need to do zoom stat again. So zoom 9. That's going to end up giving me a window where the deaths are on the x-axis and the pollution is on the y-axis. So that will end up giving me something like that. Now, if I want to do a line of best fit, I would go to number 4. Notice my X list needs to be L2 and my Y list needs to be L1 if I wanted to do this. Again, if I hit vars function Y1, I get an equation, and the equation ends up being 0.090x. If I round to 3 decimal places and there's a 0, I have to keep that 0. So it's 0.090x minus 9.363. So that is y equals 0.090x minus 9.063 was, I think, what it was. 9.363, my fault. 9.363. Okay, so this is my line of best fit given pollution as the dependent and dead fish as the independent. Now that dead fish is my independent variable, I can hit trace, hit the down arrow, and then type in 150 and figure out that that would be at a pollution index of about 4.101. So the pollution index would be 4.101, and that ends up being that. Really quickly to end, 2 things. If you end up changing what y and x are, so you end up flipping this to be y and this to be x, for example, what you might want to do is go back and at the end of the problem, change things back to their defaults and then hit enter, because if your calculator saves this sort of thing, you're probably going to want L1 and L2 to be back to X and Y, just like this. And you might want to do the same thing for the stat plot. So notice how L2 and L1 are backwards. You will want to rechange this back to L1 and L2. So that is kind of important. Also, you're probably going to want to turn your stat plot off. So when you're done, turn it back to off, because a lot of times people have their stat plots on and then they get confused as to why things are going on in a certain way. You can also turn stat plots on and off by just going up to where it says plot 1, plot 2, plot 3 on your y equals and hitting enter. So notice I just went up, hit enter, and plot 1 went on. I hit enter again, it goes off. So that might help. Finally, you may have noticed that these 2 equations here are not exactly just, if I solve for x, I end up getting this. So notice I solved I did a lot of work here, and I got x equals 0.104y minus 11.654. That was not equivalent to this. It's kind of close, but not exactly the same. And the reason is a little bit complicated, and it deals with standard deviations, and it's something you work on in AP statistics. And at the end of our course, we actually dig into standard deviations a little bit. But line of best fit deals with the distance, the squared distance of the standard deviations of like where these points are away from the line. And so that actually makes the independent and dependent variables important. So when you assign one of the variables to be independent or dependent, that actually changes where the line is. So it's not just you can't solve for one of the variables for the other one and then think that that line's going to exactly be the same.